In this case, let's say we have 249,022 as the input. Then the way it's going to proceed is I'm given the task of adding all the digits. But what I'm going to do is I'm just going to look at the least significant digit and tell my clone to add up the rest of the digits. Whatever the sum is, I'm going to add 2 to that, and that's going to be my return value. My clone, on the other hand, is also smart and lazy and doesn't want to add all the digits up himself. But he's just going to add this digit to whatever the rest sum up to and have his own clone sum up the rest. So this continues until you end up with the clone who doesn't have any digit to add up. That's one possibility. Um, so the last clone would return 0. This clone says, okay, there's 0 remaining plus I'm seeing 2. This clone says there's 2 remaining and I see 4. What would this clone return? You told?
6 plus 9.
Yes. So my clone says the rest add up to 6, and then I see 9. How about this one? True. Plus 0, yeah. Good. And 17. Or 15 plus 2. 17 plus 2. Okay. Now, this time you can actually end the recursion one step earlier. So instead of waiting until phone doesn't have any number or any digit, it can stop once it sees a single digit number. So this is the suggested base case. Okay, so we saw a similar method last class where we would always check for the 0th character of a string and then chop the string into character 1 and 1 and keep recursing until the character or string length is down to 0 or less than 10 or less than 1. In this case, instead of a string, we had a int. How would you go about processing one digit at a time? So you want to check one digit in the current round and then pass on the remaining digits to the next recursive call. How would you do that? Angel?
Use modular.
Use modular. Yes. So could you elaborate on that?
Good. Do whatever your is and mod pattern. So, that.
Okay, good. So let's say the current num is 341, 341. How do you get the last digit by doing mod? Yes, Angel.
I'm doing mod 10. 1.
Yes, good. So if you do num mod 10, that's saying if you divide num by 10, what's the remainder? Which is basically the least significant digit, which is just 1. Now, that's fine because I'm going to use 1 this round, but I need to call recursion on 34. How do you get the remaining digits? Brandon? Good. Okay, so you divide by 10 or divide by 10. So you can flip the digits into the least significant digit and the rest by using division and mod operators. Okay, so please get started. Let me know if you have any questions or if you're finished. Okay. So as usual, it's a very short method. You have one base case, and then one recursive case. Okay, so let's do the red version first. You get to the point where your remaining number is 0. So you should be checking whether num is 0, in which case you return 0. And then the recursive cases are current digit for whatever you get from the recursive call plus current digit. So if num is 0, return 0. And then the recursive case, return some digits. You pass on num divided by 10. And then you add the current digit, which is num mod 10. Okay, so that's the red version. But the suggestion was to add one step further. So the condition there would be num is less than 10, and you just return num. If num is less than 10, turn. Okay. Questions? Any questions about the homework or lab? Okay. So we'll do recursion with helper methods today. So a bit more advanced, or quite a bit more advanced. The concept of using helper isn't as advanced, but the examples we'll see are much more advanced. So let's think back at the last method we looked at last class. You didn't see the code in class, but you saw the overview, and then I uploaded, as I said, I uploaded the slides with the code filled in. So it's an ethical count, which takes a string and char and returns the number of times the char appears in the string. Yes? So then the way we approached it is, okay, we're only gonna check the first letter, char is 0. If it's same as what we're looking for, we add 1 to the return value. Otherwise, we don't add 1 to the return value. And then the actual return value is 1 or 0 plus the recursive call, whatever that returns, whatever number of matches we have in the remaining string, right? And the way we did it is to use substring. The substring 1 means give me a shorter string that starts at index 1. So that's the str.substring 1 is basically all the letters except for the 0th letter. So we continue on until we end up with the string of length 0. Now, this is a very inefficient solution, mainly because of the use of substring. Okay. Do you guys remember what a string is internally? How does a string object really store a string in itself? You sure?
Is it immutable?
Could you say it again?
Change.
It is immutable, but how does it store it? So mutability just means can you change the value or not? So it's not changeable, yes, but how is it stored? ISIS? Yes, so that is all correct. That's true for any object. But given a string object, how is the actual string, say like John, how is it stored inside that object? Lena? Yes, it's an array of chars. So when you do substring, so say like cats, and then turn that into ats. So we're just losing the first character. What really happens is you have an array of chars, C, A, T, S, and then you create a new string object which has an internal array of 3 chars, and you copy over the elements. That's how you create a substring. So what's the running time of this? Brandon? Yes, it's linear time, big O of n. Okay, and not just for substring 1, but anything, I guess, any fraction of str, if the new string contains any fraction of str, it would be linear time. Okay. So every time you make a recursive call, it's taking linear time, which is very slow. So then the question is, how do you avoid such copying? Is that a question or answer? Okay. Okay, sure.
Something like the character A. That
Yeah.
anytime you get an A, we just remove that A and make a new string out at empty state. So then if we do a for loop and do car back or like get the first car, whichever is the find the first instance, then it will immediately go to the next instance. We got rid of the first.
Using recursion,
Yeah, so you just,
what do you pass on?
you pass on a substring that's everything after that character.
Yes, we just said substring is very slow. The question is, how can you avoid using substring? Okay, so a couple ideas. Okay, so we just said substring takes linear time. Expensive means linear in this context. All right. As well, write it down here. Okay. So whatever we do, we need a way to. So let's back up. If we try to avoid substring using substring, that means we're going to keep the string intact. Somehow keep track of where we are in the string. Yes. So then one option would be, well, how about we have a static member variable for the index, which resides outside of the method. Say like index I, but it's a static method of the class. And it survives over multiple calls of the recursive method, right? So it would work if you only have one recursive method, but even if it does work because you only have one recursive method, it's not a very compelling use of member variables because member variables exist for a different reason. It's supposed to store information that's relevant to an instance or all the instances of the class, not tied to a particular method of the class. Okay. So a better option, which we'll use, is to create a helper method with an additional parameter. So why is it a helper method and not the original method? The original method but cannot change the number of parameters. One reason is because we don't want to change how the method behaves, right? When I say behave, I mean like the expected input and output should not be changed. Second thing is if we change the number of parameters for the actual method, then you're expecting the user to pass in the correct value for the second parameter, which you can't always expect. So the way you do it is you keep the method as is, the count will just have one parameter, but create a helper method, say like count helper, that takes in an additional parameter. And the main method, all it does is to call the helper method and then passes in the right parameter for this right value for the second parameter. So in our case, it's 0. So let's take a look. So again, we're not going to go with option 1. And we're going to go with option 2. So we didn't have this before, right? We just had count method, that's it, that takes in a string and char. So the way we're gonna approach it is we're gonna write a helper method. So this is the helper method. The name obviously doesn't matter, but most people like to name it as the original method name than helper. And in this context, this is called the wrapper method. Here you see why you can't just change count to have this additional I, because the user won't know what value to pass in. Okay, but in this case, we know exactly what value needs to be passed in. So I guess you have two options. You can have count helper start from the beginning and make progress towards the end, or have it start at the end and make progress towards the front. So if you want to go with the former approach, you would pass in 0 for I, and then your base case would be if I is, same as string.length, then you're done. The second approach, the latter approach would be you pass in string.length -1 to I, and then you end when I is less than 0. Okay, so let's go with the first, which is slightly more intuitive, I think. So all the wrapper method does is it just returns whatever the helper method returns. Okay, you pass in the same string, same char, and then the initial value for I, which I want it to be 0, because I'm gonna make progress from the beginning, from the left end, and end when you get to the right side of the string. Okay, so basically the wrapper method isn't the recursive one. The helper method is the recursive. Okay, so count helper. The base case, and sometimes depending on the problem and depending on the person, you may prefer to write the base case first or the recursive case first. In this case, it's probably better to start with the recursive case, just in case you don't see how the progress is made. Recursive case. Okay. So before, we always check the 0th character against X. This time, string is always the same. Well, we have I denoting which character we're currently looking at. So how would you check, or which character would you check is the same as X? Instead of 0th character, what would you check? So before, we always check the 0th character because the string gets shorter by 1. But this time, the string doesn't change. Kathleen?
You check whatever character eyes.
Yes, the ith character. So if string dot char at I is X, then the rest is very similar. If that's the case, then you return 1 plus whatever the recursive call returns. Otherwise, just return whatever the recursive call returns. So if string.char at I is the same as X, then you return 1 plus count helper. Okay, what do you pass into the recursive call? What would you pass in place of it? In place of str? What are the 3 arguments? You sure?
String, X, and I plus plus.
Okay, good. So same string. That was the whole point. The whole point of setting this up is so that we don't have to change the string, which is expensive. So same string, same target character. Now, what do we want this to be? Brennan?
Plus 1.
Philosophically speaking, we want this number to be one bigger than current I. Because we just checked I, so we want the next call to check the next character. So one bigger than the current I. Otherwise, just a recursive call without adding one to it. Okay, now what's the base case? When do you stop? When would you stop? Good. So we know that every time a recursive call is made, string doesn't change, x doesn't change. The last parameter is the only thing that changes. So it has to be something about this. And we're starting at 0 and making progress, so it must end when I is outside the bounds on the right hand side. So if I is str.length, then we have run out of bounds. So instead of trying to check char at that location, we return 0. So now you see what I mean when I said, well, I could have started at the end. So instead of passing a 0, I could have started in, I could have passed in str.length -1. And then do -1, -1. And then end when I is less than 0. So either direction would have worked. But usually people like to go from left to right. So that's how we did it. Now let's come back to this. This is slightly different from what we're discussing. So this is not a recursion topic. Could I have done I plus plus? Could I have done this? Ned?
No,
Why not?
because it increments after you call a method.
Great. So if I is currently 0, if I put I plus 1, then 1 gets passed in. But if I do I plus plus, then 0 gets passed in, and then you're incrementing I to 1. So it doesn't work. So I plus plus. So let's say I is 0. Then I plus plus evaluates to 0, and then you're incrementing it to 1. So it doesn't work. How about plus plus I? Would it work, Brandon?
It also, since regardless of whether we pass that if case or not, we return, calculate for the next one. What would happen is if the last element of the array is the right thing, then we'll also return I plus 2 in that last line, or from the I we had in this iteration, in which case it will escape bound to the array.
Okay, so let's say I 0 as before. What does plus plus I evaluate to? Pre-increment. You increment.
Values to 1.
Yes, it increments first, and then evaluates. So I plus 1 and plus plus I both work. The problem here is you're needlessly updating the value of I, which you never use after this point. So this update is unnecessary. That's why you would do I+1 instead of plus I. Did you see that? So people do this because you don't need I after this line. So there's no point of updating I. So instead of doing plus I, which also works, you want to do I+1. So I+1 is good. I++ is bad. Plus I works, but why would you do that? You don't need I after that one. What else? Yes, that's good. Okay, any questions? Did I show you? Okay, how about this? You know how we talked about ending the recursion one step early? But in this case, I suggested that we add one step early. It doesn't make the code any more complicated. Right? The purple one is not any more complicated than the red one. So that's why I suggested it. But a lot of times, if you end too early, then your base case gets a lot more complicated. And let's see that. So in this case, if I ended one step earlier, so instead of waiting until i's string.length, I could have ended when i's string.length -1. And that at that point, instead of just returning 0, I have to have if else within the base case. You see what I'm saying? So I'm showing you what would happen if you decide to end the recursion one step earlier. Okay, so I goes from 0, makes progress. Ending one step early would mean ending when I is the same as string.length -1. Okay, so I'm just literally ending one step earlier. But note that when I string.length -1, it's a valid index. So I can't just return 0. So I would have to do if the stuff in the recursive case, if string dot char at I is 0 or x, then return 1. Otherwise, yeah, I'll use else just to make it more clear. Otherwise, return 0. Okay, so that's how you would have to do it. And I hope you agree that that's a lot more complicated than this. So one way to measure when to stop is whenever you end up with a base case that has if else that resembles the recursive case, that probably means you ended one step too early. Second way to think about it is you always push the index out of bounds. That way, there's no chance to just return 0 or whatever you're doing. Right? So that would work, but you don't want to do it. So that's why in this case, I wouldn't suggest ending one step earlier. But the example we started with today, it was fine. Okay. Now, I hope you would focus. So we're going to do quite a bit more complicated example. And you'll need to know this for your lab. Okay, so first, we're going to start with the concept of sets. Okay, so a set is an unsorted or unordered collection of elements. Okay, so sometimes people call it bag of elements because there's no ordering. Okay, so that's a set of elements. And then a subset means a set whose elements are all in some other element. So set Y is a subset of set X if every element of Y is in X. So as a special case, Y could be an empty set. So every element of Y is in X, but there's no element in Y. Another special case is Y is X, in which case every element is in X, and then X doesn't have any other elements. Okay. But the point is, if there's an element in Y, that has to be in X as well, in order for Y to be a subset of X. Now, power set of a set is the set of all subsets of that set. Let's say X is the set X is 1, 2, and 3. Okay. Can you list all the subsets of X? Yitong?
It would be 1, 2, 3, 1 and 2, 2 and 3, 1 and 3, and set itself and null.
Okay. 1, 2, 3. 1, 2. 1, 3. 2, 3. 1, 2, 3. And then the empty set. Have you guys seen this symbol? That's the same as this. So a set with no elements. But anyways, are we sure these are the only subsets of X? 1, 2, 3, 7, 8. Are we sure there are exactly 8 subsets? Kathleen?
Does the order matter? So like 2, 1 would be a different subset.
Good question. What do you think? Yes or no? You got this. No, sets are unordered. So 1, 2, and 2, 1 are the same.
Okay.
Yeah. So back to my question. Are we sure we're done? In fact, it is. So this is the power set of X. These are all the subsets of X. And the way to think about it is, how do you construct a subset? Well, for each element of X, you have to decide whether it's going to be included in the subset or not. We have 2 choices per element, 3 elements, there's 2 to power of 3, 8. So 8 is the exact number of subsets. And if you see a table of this, it's probably easier to see. So we have 3 elements, 1, 2, 3. And for each one, we have 2 choices to make, either include it or not. So let's say I'm going to include all 3. Then that maps to the subset 1, 2, 3. But I want to do every combination of this. So it's include, 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 not include, not include, not include, not include, 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 not include, include, not include, not include, include, not include, include, not include, include. Okay, so those are all the possible combinations of including and not including the elements. And then each row represents a particular subset. The second row would be the subset 1, 2. The third would be 1, 3. Fourth would be just 1. Fifth would be 2, 3. 2, 3, and then the empty set. Okay. So to come up with all the subsets, what I need to do is for each element, I have to make a decision between adding it or not adding it. And there are three elements, so there are 2 to the power of 3. So these, the total number of it would be 2 choices per element. And we have 3 elements, so there are 8 of them. Any questions? So what's important is not that the total number of subsets is 2 to the power of 3, but the concept of making 2 decisions per element to end up at a subset. So if you make 3 decisions, that maps to a particular subset. That's the concept that's relevant for our discussion. Okay. So now, the question that we're going to solve is a method called can_make_sum. Takes in an int array. It's an array, so it's ordered, but we're going to assume that it's unordered. As in, no, let me say it again. We're going to use an int array to represent a set. So logically, the order doesn't matter, but we're using array, so there's an ordering, but that's not something we're going to make use of. So can_make_sum takes in an array and target int and returns true if a subset of nums adds up to the target, false otherwise. So for example, if nums is 1, 2, 3, and target is 4, then what should it return? True, because 1, 3, the subset 1, 3 adds up to 4. Okay, and then, yeah, I guess 1 to 3 is not a very interesting set, but say if target is 7, no 7, yeah, then it should return false because no subset adds up to 7. Okay, does the expected behavior make sense? Now, how would you go about doing this? So this is actually a known problem where there's no smart solution. By that, what I mean is you actually have to literally check every possible subset. You have to brute force it. Okay. So then the question now is, how do you brute force it using recursion? How do you how do you structure the recursive calls so that you end up checking every possible subset? Can you imagine how this is going to happen? This goes back to the idea of how you can reach all the subsets by trying out every combinations of including and not including the current element. Okay. So as we start the recursive call, we're going to go through each element. And for each element, we're going to make 2 recursive calls, including and not including. Okay, then we'll have total of 8 base cases, each of which represents a subset. Okay, so we start with an empty set because we haven't added any element to it. First, we're looking at element 1. So the two recursive calls we're going to make are 1, including that element, which logically represents the subset 1, and 2, a set that doesn't include that element, which is still empty set. And the recursion from there, now we're looking at element 2. Again, we're going to consider both including it and not including it, including it and not including it. And the next element, we're going to include it, not include it, include it, not include it, include it, not include it, include it, not included. Okay. So that gives us 8 base cases, and they cover all possible subsets. And we know that because for each element, we considered adding and not adding the element. And there, we would want, once you get to the base case, we want the right value to be returned. So if our target is 4, then 1 to 3, the set 1 to 3 should return false because it doesn't add up to 4. 1, 2 should also return false because they add up to 3, which is not the same as 4. Which means this should return false. Now, the set 1, 3 should return true. So this thing should return true. This thing should return true. This thing should return true. So that's the expected flow. So we're basically checking every possible subset at the base case level. If that subset adds up to the target, return true, otherwise false. So the return values will look like this. And we're not going to use the actual sets because that would involve creating a new array. So instead of actually using sets, we're going to use subset sum, a new variable. Which represents the sum of the current subset you're looking at. So empty set, it would be 0. The set of 1 is just 1. Set of 1, 2 would be 3. And then set of 1 to 3 would be 6, 3, 4, 1, 5, 2, 3, 0. Okay, so we don't actually have to keep track of all the elements, but keep track of the sum of the subset we're looking at. Then once you get to the base case, you just compare if that sum is the same as the target or not. 6 is not the same as 4, return false. 3 is not the same as 4, return false. 4 is the same as 4, so you return true. Okay. Okay, does the setup make sense? Good. Okay. Can you imagine what the helper would have as parameters? to make this possible? There's at least one parameter you should be sure about. You sure?
Now started on the index.
Okay. The second one correct. Oh, nums, target, and index. I see. Good. But we'll have one more. We'll have subset sum. Okay, so we have two additional parameters. Yeah. So the one thing that I said you should be sure about is actually the index, which you sure just said. So you know that all the parameters that are in the wrapper method are also in the list of parameters for the helper method. And then you know there's going to be an index one or two, usually one. In this case, one's fine. Because we're making progress in one direction. And then we also needed this subset sum to keep track of the current subset that we are building. Okay, so if you look at the picture again, we need this subset sum to denote the current subset we're building. If we didn't have this, then we won't know what subset we're looking at. Okay, so what would be the content of the wrapper method? Can make some. Drew?
Just returning the element.
Good. Return CMS helper. And what do you pass in as arguments? Brandon? Okay, so nums, good. So nums and target. You know are going to be the same. Index, let's start from 0 and make progress from there as usual. And then subset sum should be 0 initially because you don't have any subset. So that would be 0. Okay. I'll give you a couple minutes to finish this method. Wait. Again, base case and recursive case is going to be a very short method as usual. But the recursive structure would follow this. You're looking at a particular element denoted by I, and then you make two recursive calls. One including that particular element, one not including that particular element. And then you keep doing it. And then once you get to the base case, you check if the target is the same as the subset sum. Okay. So I'll give you a couple minutes to work on this. Let me know if you have any questions. You know how I emphasize that you should design your code before you start writing your code? Especially true for recursion. You end up writing like 3-4 lines, that's it. So you can't really write something and tinker with it to get it to work. You really want to have a clear idea before you start writing your code. So Was the red stuff make sense?
Yes, that makes sense.
Yeah. The issue with the red stuff is, so if you look at the first base case, it's 1, 2, 3. To faithfully represent that, we need an array. But we don't want to create an array for that because it's expensive.
Yeah.
So instead of keeping track of all the elements, we're just going to keep track of the sum of the elements using an int. That's the purpose of subsystem. Thank you. Good. Okay. So if I is that one. Okay. Note that nums is an array, not a class-based object, so there's no method. But luckily, arrays have this length variable. Okay, so we reached the base case, and what happens within the base case? What do you return? Oh, not this. When you get to the base case, what do you return? How do you decide if you should return true or false? Ito?
If the sum equals the target. Subset sum.
If subset sum is the same as target, you return true, otherwise false. So can you tell me the actual code?
The subset sum equals target.
Okay, good. Can someone do it without using if statement? Connor? Good. Okay. That's the base case. Once you get to the end, once you have gone through all the elements, then you simply check if the target is the same as the subset sum. Okay. Is 6 the same as 4? No, false. Is 4 the same as 4? Yes, then true. Okay. The recursive case, which is a one-liner. Question, or you want to answer this?
Yeah.
Okay, Brendan.
My thought was turn CMS helper nums target index plus 1, subset sum plus nums I, and then for that with CMS helper nums target index plus 1, just subset sum.
Okay.
Then you've got subset sum, a case with adding I, index I, and case without adding.
Good. So firstly, you have to make 2 calls. Let's first do that. So we have CMS helper. CMS helper. Okay, we know nums and target don't change. Okay, and for both of these cases, we know we have to check the next element. So actually, how does I change? What do you pass in place of I? If you want to check the next, if you want to check the next element. So you currently checked ith element. Then in the next call, you want to check the next element. How do you do that? What do you pass in? ISIS? Good. I plus 1. Now, the difference between these two calls is one represents including the current element, the other represents not including the current element. Including the current element means adding the current element to the subset sum. Not including it is just keeping the subset sum as is. So if you look at, say, 3, including 3 means adding 3 to the current sum. Not including it means not adding it. Including 3 means adding 3 to the current sum. Not including means not touching it at all. So it's gonna be current subset sum plus the element you're looking at, which is nums at I. And the second call is the current subset sum, but not adding anything to it. Now, how do we combine these two? Well, you can see here, if either of them is true, you want to return true. So which logical operator does that? Paul? Or good. So that's what, so this is what Brendan said. So that's it. So we have a base case, checks if I has gone out of bounds. If so, then return target equals subset sum. In the recursive case, you make 2 calls, one with the current value added, one without, and then take the OR. Okay, so it's very short code that ends up implementing this. Now we're going to make a slight optimization. So you see that in the end, what we end up doing is we add or we check if the subset sum is the same as target, right? Can we have the same effect without having this subset sum as a separate variable? If you're checking if 2 things are the same, then it's the same thing as if A equals B, then A minus B must be 0. So instead of using subset sum, we're going to update target. The target starts off as 4. When you include an item, an element, we subtract. When we include an item, we subtract. When we include an item, we subtract. Okay. So not including, no, not 0, it's going to be 4. Including would mean 2, not including 4, including -3, not including. Including 3 would be -1, not including be just 2. 1. My pen doesn't work. Okay. Yeah, so basically the idea is instead of having target fixed and updating subset sum and checking if they're the same at the end, we're not going to have subset sum. And then every time we include an element, we subtract that from target. And we just check if it's 0 at the end. Okay, so we don't actually need subset sum. Okay. Again, the main thing is instead of keeping target fixed and incrementing subset sum and checking if they're the same, we're not going to have subset sum and subtract from target every time we include an element and check if target ends up being 0. If it's positive or negative, that means the target is not the same as the subset sum. Okay, good. Thank you, and I'll see you on Friday.